For this problem, we're finding the values of x that cause horizontal tangent lines for this function. Now, what is a horizontal tangent line? Graphically speaking, a horizontal tangent line is where the graph goes horizontal very briefly. But how can I determine that algebraically? With calculus, you take the derivative and set it equal to 0, and then find the values of x that cause that to happen. So with that in mind, I'm going to take this derivative, set it equal to 0, and solve. One thing before we do that, though, is I always encourage you to rewrite any sort of trig power as bracketed. So this was sine squared of x. I want to write it as sine of x all squared. This is how you should always rewrite this so that you can more easily note that a chain rule is going to be involved. So let's go ahead and take this derivative. We've got f prime of x equals 8 cosine of x. Chain rule says this 2 will come down in front, so we have plus 2 times sine of x now to the power of 1 times the derivative of the inside function. That's what the chain rule says. You leave the inside function alone, then multiply by the derivative of that inside function. And since sine is the inside function, we multiply by its derivative, which is cosine, on the outside. Okay, remember, we're setting this equal to 0, and now we need to solve. What I want to point out is that both of these terms have a cosine in them. They also have a factor of 2 in them, so I'm going to go ahead and factor that out. I'm going to factor a 2 cosine out, and then here's what I'm left with. 4 plus sine of x. Now that I've factored out a 2 cosine x, I have 2 cosine of x times 4 plus sine x. Remember, I'm still setting this whole thing equal to 0, so it's my job to figure out where this factor is equal to 0, as well as where this factor is equal to 0. Let's start with this guy, because he's actually the easiest. So 4 plus sine of x is another, and again, this is whole equal to 0, so there's another way of saying sine x equals negative 4. But if you remember your unit circle, sine never goes higher than 1, nor does it ever go lower than negative 1, right? Sine kind of oscillates like this between negative 1 and 1, and because of that, it never goes as low as negative 4. So this will never give us any solutions. However, 2 cosine of x will give us some solutions. When is 2 cosine of x, or when is just cosine of x equal to 0? If you know your unit circle, you'll know that occurs at x equals pi over 2 and 3 pi over 2. At least that's your standard unit circle from all the way from 0 all the way around to 2 pi. But the problem with that is there's probably a bit more, right? So 3, we know we can keep going around the unit circle. So the next one that you could get is 5 pi over 2. The next one after that you can get is 7 pi over 2. The next one you get after that is 9 pi over 2. You might be sensing a pattern here. This is 1 pi, 3 pi, 5 pi, 7 pi, 9 pi, all odd numbers divided by 2. So the way to rewrite odd numbers divided by 2 is by saying the following: 2n plus 1 pi over 2. 2n plus 1 is an odd number, so 2n plus 1 will be odd, times pi over 2 will give us all the answers we're looking for.